we're just going to look at for loops, right?
Yeah.
Now, if you look at a for loop, the idea is that generally, as I said, you don't want to be like, it's to make your life easier,
Yeah.
so that you don't have to like type 50 lines of code. You can like type 1 line of code, and it's usually where there's change.
Okay.
So basically what I mean is, say you have a list, right, of values. So you have, say, 1 through 5 and 6, right? And then just remember, like, random list of data. And what you want to do is you want to print each value.
Okay.
Just as an example, right? You can either like manually say print the first value, then print the second one, and so forth,
Yeah.
right? Or what you can do is you can just put it in a for loop, and you say something like for I in V, right? But let's call this big V. Let's call this big V, and let's just say, like, as an example, these are like voltage readings from EBN crack,
Okay.
as an example, right? And you get this list, and you just want to see the what's the stuff, like you want to see the readings. Like, you can't really see it, like you want to see each one, like it's just a lot, right? So then instead of calling it I, you can call this small v over here, and then you can call this big V here, right?
Yeah.
So the idea, like, you understand how a for loop, like the general format of it is that it looks something like this, that you have so you say for B, or no, you say for object in list / array, right? Array, and then you have your indentate, like you indent inside, and then code that is repeated until all objects in list have been called or looped through. I'll just say loop through. Okay, loop through. So as an example, so if we say for V and V, you're gonna say now, like, remember we want to look at these voltage readings here.
Yeah.
So we say for V and V, and I say, yeah, so I say for V and V, and then we just say print V. If I just say print V, right, I say print V and I run the thing, we're gonna see we get 1, 2, 5, 6, right?
Okay.
But the cool thing is you can do math things to this. Like, say you want to square each value in there, right? As an example, you can square them, and then it's gonna square each value. Simple, right? Or if you want to add 5 to them. But what's nice is with loops, or with for loops, is that whenever you see this value that's changing here, like this is the value that's changing. Do you see that? If I run this thing, you'll see that, so each V represents 1, 2, 5, 6, right? Now, what we could do is as I said, we can just print each one manually, but that's gonna take a long time. Or you can just put in a loop and it runs, right? An example of where I used a loop in my own, like, engineering studies, an actual practical application, was in a module called MIA 321. 321.
Okay.
And I had to design a ventilation system for a mine, and it's like a grid mine, right? So you have this grid, and you have to calculate what the pressures are, or no, what the volume is of the mine, right? And it's a grid, so it's like, you can imagine it's sort of like a channel, and then a channel, and it's a lot of stuff to calculate, right? And each one is kind of different, but with its own specs. So what you do is you just know what the specs are of each, like, let's say the cross-sectional area of each, right? And then you have to multiply that by the height, by the length. But if the lengths are varying and the cross-sectional is varying, then all you do is just put it in a loop, and then it will, like, do it all for you. Like, in this case, you're going to use a for loop. So a for loop is when you know how many times you want to loop. It's simple, right? So use a loop when you know how many times you want the thing to loop. So the logic is for loop, use for loop, use for loop, right? When you know how many times you want to loop. You know how many times you want to loop, right? So an idea, wait, let me just cut this actually that's like the theory, right? We'll keep that there. I'll move that here, right? So voltage for EV input. Okay, put that there. Okay, so yeah, so basically, just you understand that if we run this, so if you run this, we're gonna get 1, 2, 5, 6, right?
Yeah.
Now, say, okay, so I'm saying here, you know how many times you want to loop. So usually, in this case, if I say for v in range v, you want to loop through the whole thing,
Yeah.
right? If I want to loop through, say, the first 3 values of v, then so loop through first 3 values of, or first 3 voltage readings of what's this thing, of v, right? Then what basically, like, what you're gonna do is just gonna say for I in range. Now if they only want the first 3, you need to create an index, because you need to set a range of how many, like, which values you want to go from 0 to the second index. Like, you're familiar with indexes, right? Okay, so with a list, you know that you have so let's just call it I, for example, right?
Yeah.
For index. So the first index in this case, which is 1, will be 0. Like, it's basically the address value in the list. The second one is 1. So there's 2. The index of 2 is 1, right?
Yeah.
The index of the first one is 0. The 5 is 3, and then the last one is 4, right?
Yeah.
So in this case, there's only 0. There's only like 0, 1, 2. Okay, no, I made a mistake. This is 2 and this is 3, right?
Yeah.
So if you add another value and say you make it 7.5, right? Then so 0, 1, 2, 3, you're gonna make it as an example 4.5, right? So no, sorry, you're gonna make it 4 because the index is 4, right?
Yeah.
But there's only 4 indexes. So say you want to loop from the first 3, so you want to loop the first 2 indexes. You want 0, 1, 2. So you're gonna say for I in range, and you're just gonna put a 3 here, and then you put a 3 there. You tell it how many times you want the thing to loop. It's basically the same as saying range 0, 3, 1, right? Which gives you the list 0, 1, 2, right? Same thing. This default, like, you just put a 3, it's the same. Okay, so range. So basically, when you know how many times you want to loop, then that's like, you know, use a for loop, because you know how many times you want the thing to loop. Yeah. Remember what I was saying now about these. So we want to print like the first 3, because we know how many times we want it to loop. So you just put a 3, and now if I run it, just copy this. Remember, here's v, right? And I run it. So there's v, and then I run it. You have here vi. So remember, I takes on the this is I is first 0, I is 1, then I is 2.
Yeah.
So it loops the first time, you know it's 0.
Yeah.
It loops the second time, you know it's 1, and it loops the third time, you know it's 2. So just it's 0 first. So vi 0, it's going to be 1, right? So if I make it 1.5, we'll see that it will change. See, it's 1.5, 2, 5. But like, basically, use a for loop when you want to loop, right?
Yeah.
When you know how many times you want to loop. Cool. Yeah. Then when you want to use a while loop, so let's look at while loops, right? Use a while loop. The while loop when you do not know, when you want something but you don't know when you're going to get it. Like when you want something, when you want a certain result, but you don't know when you're going to get it. But you don't know how many loops you need to get it. But you don't know how many loops you need to get. I'll give you an example. How many loops you need to get it, right?
Yeah.
So as an example, right? say okay, below. Say now we're gonna use this. I'm just gonna keep using these EBN voltage readings.
Okay.
So I come here. So we have V is equal to 1.5, 2, 5, 6, 7.5, right?
Yeah.
Now, if we look at these things, let's run through this. Let's assume all of these are just integers, right? Let's assume they're integers. Now we want to remember this can be any list of data, and we want to run through this until we find an even number, like until the voltages say an even number. And I know it's something random, but we don't know when we see here an even, right? But remember, this can be any. You get different lists, and when the number is even, it should stop, right?
Okay.
So the question's like, if loop through V until an even number is reached, right? So look at this thing, and now, so there's our voltage readings, and now we don't know when we're going to get it. So if you don't know, basically if there's uncertainty, you use a while loop, right? And you understand, like, they're not going to say directly loop through this, but you're going to see that there's going to be stuff that it's changing, right? Like they're going to be like go through the list until they find the first 3 values or something like that. Like you don't know when, so you just know like it's a loop, basically, right? So you're gonna throw a while loop, and then you're gonna say while, but now the conditions. Note this, right? And it's very important. The conditions for a while loop, conditions for loop, or no, for while, okay, conditions while loop are counterintuitive, right? So do you know what I mean by that? You don't. Okay, I'll explain. Right. So when something's counterintuitive, it's basically the opposite of the way that it is, right? So when you want to set up the conditions, first you know they're counterintuitive. Okay, don't worry about that. You know they're counterintuitive, right? Let's put that there. You know they're counterintuitive, and then you also know that they are. Okay, well we're looking at while I'll just get rid of this. Okay, the conditions are counterintuitive, and then when you want to set them up, you have to ask yourself, ask the question, when should the loop run? So that's when you want to know how you should set up the condition. When should the loop run, right? And then if you get multiple conditions, that's given. Just note multiple conditions. For multiple conditions, start with one condition. Ignore the rest until you've got condition, and then ignore the others. Okay. So now we got that, right? So now we're looking at this, and we want to loop through V until an even number is reached. I know we see an even number there, but it could be at the end, it could be somewhere there. So let's just see if this works. And then we should count. We should return reached, and then return so number of loops, and the number, right? So we're going to run through this thing until we reach an even number. Now, if you want to, okay, so yeah, okay, so then also note that the condition is something called a Boolean, or Boolean object. Now, the Boolean object is true. It's either true or that's basically it, right? It's true, false. That's basically a Boolean. It can either be true or it can be false. Okay. So over here, when the loop runs, there's a condition. So when the condition is true, it runs, right? So what I mean by that is, so if we condition is true. So remember, we have something that looks like this. So we have while condition. I know it's not theory I'm doing with you guys now, but it's cool. You like looking at what I'm doing here. So you say while the condition, and then it's just the code that repeats. Code that repeats until condition is false. It's false, runs, so basically code will repeat or loop slash repeat until the or while the condition is true. Okay. Okay. And remember, I note that I used the capital T because it's literally defined with a capital T. So if I anyway, but let me condition. Yeah, so it's true, it runs, right? True, loop runs. Then we all know that if it's false, then it stops, right? So once you get that idea, then everything makes sense after that. So yeah, there's some theory there. Let's just, so we're not confused, put that there, right? And then let me say EBN prac. You also following?
Yeah.
Cool, man. Yeah, we also starting. Yeah. So you see there's now this list, and what we're going to do is we're going to loop through V until an even number is reached, return number of loops in the even number, right? Actual even number. Okay. So now we understand we have a condition. So now we ask ourselves, when should it be true? It should run, or when should it run? It should run whilst the number is odd. It should run whilst it's odd because it's going to run until this odd number that stops when it's even, right?
Yeah.
So you ask yourself the question, when should it run whilst it's odd? So you need to define, so
that's why it's counterintuitive.
Exactly. So you say number, so you define a number. This is the number that, this is the number that is going to be used as the reference, like the number inside V, right? You can even call it small v if you want to, because that's a big V here, that's the small v for the voltage, right? And then we're going to say V, and now, have you ever heard of this, right, like this modulus thing, percentage 2? Okay, so percentage 2 is like basically, it's very simple, right? It's like if I come here and I below.
Is that the error thing?
No, it's not an error thing. So it basically says, so if I say print 5 percentage 2, it says if I take 5 and divide it by 2, what is the remainder? So it's like the remainder, it's like a remainder thing. So it's always going to be 1, right? If we make 10, the remainder should be what? 0, right? If we divide it by 10 by 3, we know the remainder should be 1. If we run it, it's 1, right? And the whole idea of that is like you can use the same thing, like if you noticed with all even numbers, and if you divide all even numbers by 2, you agree with me, there'll always be a remainder of 0, right? If you divide all odd numbers by 2, the remainder will always be 1. So we use that to our advantage, and then we just say while V percentage 2, and we set that equal to we set that, so we ask ourselves the question, when should it run whilst it's odd? So V percentage 2, the remainder should equal to 1. Okay, so now, but remember, this condition needs to be defined before, remember, this needs to be true before the loop runs, but we haven't defined V, small v. So small v will be, here we'll make it, you can make it anything, but it should be true. So we can make it 5 as an example, just as long as this is odd. So, but you can't make it 4 because then it will be false, right? So we make it odd. So run the thing, and now what we want to do is we want to loop through this until an even number is reached, right? But we need to define each entry in here. And remember what I said about indexes. So with indexes, you need to index through this list. Are you familiar with index? So remember an index is looks like this, right? So basically how the address of values in a list or an array. So if I come here and I say like it's basically 0, 1, 2, 3, 4. Okay, so this first entry has a 0th index. The second one has the first index. It's like the address. Where is it in the list?
Okay.
Makes sense, right? So what we need to do is to call, say you want to call this one, just as an example. Say you want to call v5 as, or like this one, 5, right? Then what you can do is, okay, I'm just going to get rid of this just to give you an idea. If I say print, and I say v, and I put here, so this index is 2. If I put 2 and I run it, you'll see it will give 5, right? Because if you put, say, 4, it should be 7, right? You get the idea, okay? So we're coming back to this one. And remember, we want to loop through this thing until we get to an even number. Okay, and we don't know when we're going to get the even number, so we don't know how many loops it should be. Now, so we say v percentage 2 is equal to 1. Yeah, and now inside the code, now we've defined this. You see this is here, and this is true. You see that. So basically the whole thing is true. Great. Okay. So now, okay, loop through until even number is reached, return number of loops. Okay. So now what we need to do is because we need to now go through this list actively, we need to define an index, right? So we need a thing that it's first 0, then it's 1. Like the first loop it should be 0, right? Then it should be 2. So all you do is you define the index. So you say I is equal to 0, right? And then you're going to say v, small v is equal to big V I, right? Because it's going to be 0. But then what you need to do is you need to, the increment needs to move. Like you need, the next loop it needs to be 1, the next loop it needs to be 2, right? So you need to say I is plus, or I is equal to I plus 1, right? But remember, that's exactly the same as saying I is equal to plus 1. The same format.
Why is it plus one?
It's the same thing as saying I plus 1.
Okay.
Same thing, it's just shorthand. So do you understand this? Like basically, so I is going to be 0. Yeah, I must keep changing. So I'll be 0, so it's going to be 0 plus 1, right? And then I'll equal to 1. The next loop, I'll be 1 because it's updated from the previous loop, and then 1 plus 1, which will be, then I'll be 2, and then it just keeps going, right?
Yeah.
So, but the shorthand notation is plus or equals to 1. I prefer that, it works. Okay, so now do you guys agree with me that it's going to be indexing now? Now v, but it's very important that whatever the main condition here that's changing, there should be some value that's changing in here. And remember, it's exactly the same with a for loop. Remember, in a for loop, this I value is changing, right? Over here, or that's what's changing. You don't necessarily have to use this value here, but in a loop, in a while loop, you have to use this value, because if it's not changing, if this value isn't changing, then it will always be true, right? You understand? So basically, if we left out this, if we just left this out, we left it out, and outside of this loop, right outside of the loop. So when you go outside of the loop, you're basically going to say, and you want to know what print I is. You never put a print inside the while loop. You put a print initially. If you put a print inside, it's going to like print the thing, and if it's infinite loop, it's going to keep printing, your Drupal is going to shut down. Okay, and it's message test, it's the worst, because it shuts down, and then you can't do anything, and then the computer, they have to restart the computer, and they're not going to give you extra time, right? So it's a simple trick. Just discipline yourself, don't put the print inside. And that's why you have to practice a lot of problems before the test.
Yeah.
So you know, I'm not going to put the print inside. So if I run it now, you put a print outside to see if you get a value. If I run it, you're going to see that it's just going to, a star will stay there, right? And if the star's not going away, it means that it's an infinite loop. Because now it's running. The reason why it's an infinite loop, so let me just stop it. If you want to stop it, you go to the kernel, and then you just say restart, and no, actually wait, you go to the kernel, and you go to clear, restart and clear out. Okay, now if you do, the star's gone, thing's done, right? It's not going to run anymore. Okay, but in this thing is, my computer is very good, so I can like run it as long as I need, like probably forever, and nothing happens to my computer, it won't shut down. But your computer, or the computers that you're using to write your test on, they are not so good, right? So they will naturally shut. Like if you leave it, you can leave it and see what happens. But rather, if you see a star and it's not going away, just go to kernel, restart, clear out. Okay, it means you got an infinite loop. And how you know you have an infinite loop, and trust me, it still happens to me. I'll get an infinite loop if I'm coding something. Like, it happens to everyone, right? But with Jupyter, you don't want to play that game. Like, that print inside and then it just prints, because it's alright running like without a print inside there. But the moment you put a print, remember, is a function that's actually taking whatever you're doing and letting you see something. And that takes memory too, like an action. Like, basically, think about when you want to do something, a decision. To make a decision, it takes time and it takes like energy, right? It takes, so if you put the print inside, every time it prints, it's going to take energy from the computer, and eventually just computer can't like handle them, so it just shuts down. So just don't put the print inside. And then, and how we know we have infinite loop is this condition over here. It's always, as long as this is always true, it will always run, right? This condition is only going to stop when it's false, so you have to define it inside. So v, remember what in this case the question is, we're looping through each v value, right?
Yeah.
So we need to define each v value in the loop, because they'll be looping through it. So you say vi, okay, because this represents each value. If I run it now, we'll see we get 2. So it means it stops at the second one. Twice. And then what is the number? Then we just say print v. If we run it, it will probably be 2 and 2, right? Because it's 2 loops, the second, the even number is 2. If I say we make this 21, and I make this, say we make right at the end, we make it 70, and I run it now, I will see that, right, let's run it now. Why does it say 4 and 6? Oh yeah, because you see that's, if we make it 61, we'll see that it says the last one is 5 and 70. So you get the idea, like a loop, you use a loop when you don't know when you're gonna, how many times it should loop, but you know, like, this is a condition you want. There's something that must be met. Okay. Yeah, this is the indexing. It's calling this value from this list, yeah. But remember, this could also be an array. I could say np dot array. It's the same thing. The indexing works exactly the same for a list and an array, right? So, but then just have to define np. So I'm going to say import numpy as np, right? And I'm going to run it, and you're going to see it works exactly the same.